Okay, hey kids, how's it going? We're back at her again for day two. Nice job, whoever it was. I think two people watched the videos that I posted yesterday, so thanks for the video. I mean, thanks for doing that. I'm just going to keep doing this until someone tells me to stop. Like I said, if you need me to do something different, just let me know, and I'll see what I can come up with. All right, so task number 4 is one of my favorites. Wish I was able to do this with you in class, but whatever. This is the egg launch contest. So it says Ms. Rhodes' class is holding an egg launching contest on the football field. Um, Teams of students have built catapults that will hurl an egg down the field. No, we would not actually do this ourselves if we were in class, but it's still a fun problem for a math geek like me. Anyway, Ms. Monroe's class will judge the contest. They have various tools and ideas for measuring each launch and how to determine which team wins. So here's what we got for Team A. Team A used their catapult and hurled an egg down the football field. Students used a motion detector to collect data while the egg was in the air, and this is what they came up with. When the egg was 7 feet from the goal line, it was 19 feet in the air. 5 feet later, 5 horizontal feet later, it was 90 feet in the air. And then 2 feet after that, it was 101, and so forth and so on. So, first question is, what do you notice about the height of the egg as the distance from the starting line increases? So, tick, 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 that's the class dojo thing going. Oh, I call on Zoe, and Zoe says, I notice that the changes are not the same. And I say, great observation, Zoe. Yeah, that's absolutely right. So in the first 5 feet, the egg goes up like 71 feet. In the next 2 feet, the egg only goes up 11. And then in the next 5 feet, it starts to come back down again. So from that, we can infer that if we were to make a graph, without graphing, what would the shape would be? What a big surprise, since we're studying parabolas, that the shape of an egg flying through the air would be a parabola. Oh, bad. Anyway, whatever the shape is, a parabola would be a parabola. Okay, Team B's egg flew through the air and landed down the field. The group of students tracking the path of that egg determined an equation that would represent the path the egg took. Okay, describe the shape of the graph describing Team B's egg based on the function given. So let's brainstorm. What do you notice? Well, we notice that since A is negative, the parabola is opening down. Talked about that yesterday. This little negative thingy right there means the parabola is going to open down. What else do we notice? Really not much. Here's something weird. It started at negative 40. So that's strange. They obviously didn't launch their egg from 40 feet beneath the ground. And so what that tells me is, if this is our football field and this is the goal line, they must not have started at the goal line. They must have started like somewhere right here, and then the parabola looks like that. So if I continued it, then here it would be 40 below the ground. But again, they didn't start there. They started somewhere in front of the goal line. So anyway, those are my thoughts. Okay, Team C, they did the best job with collecting the data because they made a graph. So that's the easiest for us to work with, I think. So what are some things that we noticed? Okay, so it started about 11 feet from the goal line. That's one thing that I notice. It lands about 27 feet from the goal line. So that means that it went about, what's 27 minus 11, 16 feet this direction. And then it looks like its highest point is about, maybe 88 feet above the ground. So I feel like a graph is a good way to go in this case because we can get a lot of information from that just really pretty quickly. All right. Okay, so do you notice first group was a table, second group was an equation, third group was a graph. So now what we're going to do is we're going to take some time to put all of these together, because at this point we're not able to answer this question: which team do you think won the contest? If you think that the winning egg went the highest, then you know how high this one went. You don't know how high this one went, and you have an idea of how high this one went, 101, but it's possible 14 is not right in between 12 and 19 if you stacking what I'm chopping. So that could have still been on its way up when it got to 101, or it could have been already on its way down. And then if you think the winner is which one went the farthest this way, we have that information for this graph, but we don't know that for these or for these. So we got some work to do. All right, so let's do that work. Using the data from Team A, determine an equation that describes the path of the egg. Describe how you found your equation. So this is the equation that I came up with, and the way that I would describe how I came up with that is I used Desmos. So that is not something that I would expect that you would be able to come up with on your own. So then it says on the graph below, graph the path. Yeah, that rhymes. Graph the path of Team A's egg. So let's go back and look at this table. In fact, let's do better than that. Let's grab this table so we don't have to keep going back to it. And put it on that other page. Nope. Okay, so there's our data. Here is our graph. Let's start throwing some points on there. So at 7, it was at 19. So 7 and 19 gets a dot about there. Then 12 and 90 is about there. Then 14 and 101. It's about there. Bryson, put your phone away. 19 and 90. So now we're on our way back down. 21 and 55. And 0. Oh, 24 is where it hit the ground again. So this is what I was talking about when we don't really know how high this egg went in the air, because this should be symmetrical, and it's not. Yesterday I was having trouble with this tool. Yeah, I don't know why it keeps going away like that. Anyway, if I tried to draw a parabola here, then it would actually be maybe a little bit higher than that. So when it says, what is the maximum height the egg was hurled, we don't know that for sure, but I'm going to guess that it was a little bit higher than 101 feet, maybe maybe like 103 feet, I don't know. And then how far was the egg hurled? Well, we know it landed at 24. We don't really know where it started. Maybe right around 3. So if I go 24 minus 3 equals 21. So about 21 feet. But again, those are just estimates. We could graph this on Desmos and then figure it out exactly, but we ain't gonna. All right, using the equation from Team B, generate a table of values that shows different locations of the egg as it flew through the air. So let's grab the equation for Team B and bring that over to there. And then what we would do there is we would, pick some different x values to plug in to that equation and see what we would get for y values. If I go back to here, they went 7 through 24. If I look ahead at this one, it looks like we want to go up to about 27, and they're going by 3. So let's just do that. So I'm going to go 3, and then 6, and then 9, and then 12, and then 15, 18, 21, 24, and 27. So what I'm going to do is I'm going to pause the video real quick. I'll take all of these numbers, plug them into the function, and then write down what the answers will be. And then we will use that to make a graph together. So I'll be right back. Okay, that's kind of a train wreck, but that's the data that we got. So it looks like when that's 3 feet away or whatever, the egg was about 9.8 above the ground. And then at 6, it was shot up to 45.2. Is that a little better? Then 9 is 66.2. 12 is 72.8, and then we start dropping again. So 15 is 65, 18 is 42.8, 21 is 6.2, and then I stop there because at 24 you can see it starts going negative, so it's underneath the ground or whatever, so I'm not going to mess with that. So the flight looks like that. Okay, so now let's answer those same questions that we did for the other one. For this, the maximum height, you can tell from my beautiful drawing, is, I don't know, looks like it's just over 70 feet, so maybe 75 feet-ish. We could have a big argument about that in class. And then it looks like it was in the air for about from 2 to 22, so 22 minus 2 equals 20 feet horizontally this way. Okay. All right. So now I got all that. So no, now we need Team C. So Team C, using the data to generate the table. Well, I don't want to because Team C, we already had the graph, and that's what we're going with. So what I'm going to do is I'm just going to steal this graph and put it over here. Let's just paste that bad boy right into here. So there's our graph. So if we wanted to, we could grab the different values, but I don't see how that does us any good. So let's answer the main questions. So maximum height. This one looks like about 88 feet. I think that's what I said on the other slide. And then the distance is equal to about 26 minus 11-ish, which equals 15 feet. Okay, so now we are ready to figure out who won. So if it's a height contest, which team wins? Well, let's go back to Team A. Maximum height was about 103 feet. For Team B, they're losers. The maximum height was about 75 feet. And for Team C, they got up to 88 feet. So I would say for this, I would say Team A had the largest maximum height. Okay, if it's a distance contest, who wins? So back here to Team A, they went about 21 feet horizontally. These guys, very close, went about 20 feet. And these guys went about 15 feet. So let's give the distance to Team B just to spread the love a little bit. So if it was a distance contest, I would say Team B, but it was close. Okay, find a method for determining a winner so that so neither Team A or Team B won. So in other words, how could we rig it so that Team C won? I don't know, we've had some interesting discussions about that over the years. Some kids have figured out that if you could find the area of all this, that would tell you the time that the egg is in the air, which is pretty fancy pants. So let's just go with that. So maybe Team C wins if we are going with total time in the air. But we don't really know. All right, so that is task, whatever, task, I don't know, what was that? Oh, task 4. Okay, then task 5, you're supposed to make up your own story. Write a story to describe the 3 graphs pictured below. And you don't have to use eggs. You could talk about somebody throwing baseballs or kicking soccer balls or fireworks going off or rockets flying through the air or whatever. So I will let you use your own creativity to figure that story out on your own. All right. So today's Friday, so I won't post another one of these bad boys until Monday. Hope you guys are figuring out which way is up and which way is down out there in this crazy new world. Let me know if you have any questions or you need any help. Talk to you next week.